Hello, this is Gang Lee at Yonsei University in Korea. Thank you for inviting me as a keynote at IPC 2020. Today, I'll talk about the Smart IDM project that I'm leading as a project leader. Smart IDM is being developed as an ISO standard. The former name for Smart IDM is ISO 29481 Part 3 Information Delivery Manual Data Schema. I'll first briefly explain what IDM Information Delivery Manual is, and I explain what motivated the Smart IDM project and how it is being undertaken. Since IDM schema is a data model for IDM, let me briefly explain what IDM is first. IDM is ISO 29481 Part 1. It defines a methodology for specifying information requirements of a construction project and their use cases. Quite a few documents roughly explain IDM as a process. Even Building Smart International, an organization to create and promote information standards in architecture, engineering, and construction, used this diagram for a long time to promote the three major BIM-related standards in easily understandable terms to non-technical people. But it is technically incorrect to say IDM is only about a process, although it is true that a process is a core component of IDM. The essential goal of IDM is to specify information requirements. The information requirements are called the exchange requirement, ER, in IDM. The two main components of IDM are the process map, PM, and the exchange requirement, ER. The IDM standard defines how these PM and ER should be specified. This is what a PM looks like. ISO 29481 Part 1 recommends the Business Process Modeling Notation, BPMN, as the process map modeling method. Here's an example of process map specified using BPMN. This is what an ER looks like. To make a PM and an ER a full specification, the IDM standard requires a header section which includes a title, a unique identifier, and a change log, and an overview section which includes a description, a use case, aims and scope, and business requirements. Both an ER specification and a PM specification have the same structure. Here are some examples of PM and ER specifications. So why is IDM important? First, IDM is important because it's the first step toward the standard data model development and implementation. Once an IDM is specified, the ERs in an IDM are developed further into or mapped to model view definitions, MVDs. An MVD is a subset of data schema of a standard data schema such as IFC, CIS2, or GBXML. A standard data schema can be implemented as a database management system or software applications. The second reason why IDM is important is that it is also the starting point of the delivery and management of a construction project using BIM. ISO 19650 defines an information management method using BIM. And it requires specification of information requirements, IDM, as a starting point of any BIM projects. Thus, as the number of BIM projects grows, the demand for IDM also increases. Then what is Smart IDM and why do we need it? There are many industry challenges due to the lack of enough IDM specifications. Probably you've seen BIM projects which does not really have a clear definition of information deliverables at the end of a project. Currently, COBE, Construction Operations Building Information Exchange, is the most commonly used specification for clients' information requirements at the project handover phase. COBE works for some types of projects, but not all types of projects. To expedite the use of BIM throughout the life cycle of a project, we need a lot more IDMs and MVDs like COBE. We are using LOD as a way of checking the required quality of submitted BIM models. However, LOD is merely a rough modeling guide, not an explicit information requirement specification. So we need to develop a lot more IDMs and MVDs fast, but currently IDMs and MVDs are being developed manually. For example, an ER consists of a long list of information items, but they are specified and checked against use cases one by one, all manually. This process is very time-consuming and challenging. Another challenge is that if there are two similar projects, information requirements may not be exactly the same, but similar. For example, if there is an IDM for a hospital project, we can save a lot of time if we can modify and repurpose the existing hospital IDM to develop a new hospital IDM specification. However, currently all IDM specifications are developed and shared as an individual document file, such as a Word or PDF file, not as a data file based on an IDM data schema. So it is difficult to find and track which part of the document is associated with which information items or use cases. And the entire list of ERs needs to be examined if a new process is added or the existing process is changed. Moreover, each organization has its own IDM specification format. The formats are not only stylistically different, but the contents are also different. Also, the section names are different. For example, some organizations call a summary section a description section, some an executive summary section, and some a highlights section. Overall, all of these make the development of PMs and ERs and eventually the mapping between an IDM and an MVD an enormous task. Thus, we need a standard terminology and a standard relational framework to facilitate the development and maintenance of IDMs and MVDs. By developing Smart IDM, we are trying to facilitate the exchange and development of IDM specifications to provide tight links between IDM and other related standards and to automate real-time MVD generation. ISO 29481 Part 3 IDM schema is an interpretation of ISO 29481 Part 1 into data schema to make IDM specifications machine readable. ISO Strategy 2030 defines SMART as an abbreviation for standards, machine applicable, readable, and transferrable. The IDM schema is also referred to as IDM XML schema or IDM XSD because it's specified in the XML schema language. There have been many existing efforts to develop IDM and MVD methodologies and also to develop IDM schema. There are several proof of concept demonstrations, and here are the list. And here are the video. So once you have the IDM schema, then you can automatically reformat your documents using style sheet, or you can also develop MVD automatically from IDM specification like this. There are also some commercial tools that support the IDM methodology. BIMQ is one example. However, all these systems were implemented using an IDM data schema developed proprietarily, which means that the data generated in each system cannot be easily shared. Development of the Smart IDM. The proof of concept was demonstrated in 2012 at a Building Smart International Summit using XPPM. The project was incubated from 2014 to 2019 and officially approved as a BSI, Building Smart International project in April 2019. A total of 46 IDM experts from all over the world participated in the development of IDM schema. There were several IDM frameworks proposed by previous studies, and they were all examined. Also, we reviewed 188 IDM specification sets. Here's the comparison chart. So for about a year, we developed the IDM schema in collaboration with SAN, the European Standardization Organization, and the Building Smart International Use Case Management Group through many meetings and 3 rounds of Delphi survey to reach a consensus on the proposed IDM schema. So what does the IDM schema look like? In IDM schema, IDM documents are referred to as IDM specifications, and ER and PM documents are referred to as ER and PM specifications. So in terms of data schema, IDM and ER and PM are concept, and the documents or the specifications are the instance. The ISO 29481 Part 1 standard, which was developed 10 years ago, does not include a use case as the core element of component of IDM, but the significance of use case and use case specification activity has increased, particularly in Europe, and we had to think about how to position use case in IDM, or what the relationship between use case and IDM and use case and PM, process map, and so on. Use was a little more complex because we have a use case. So we talked about the differences between use and use case, and our resolution was use case is a specialization of use. For example, if we have beam use 4D modeling, and use case is a 4D modeling with a purpose. So are we using 4D modeling for complex sequence coordination? Then that case is the use case of 4D modeling. Or if we are using 4D modeling for schedule management, then that's another use case of 4D modeling. So we viewed use case as a specialization of use. So in the data schema, use has definitions and so on, but use case has aims and scope and more information, the target project phase, roles, and so on. And similar to the distinction between IDM and IDM specification, we can also instantiate the use case to create a use case specification. As mentioned earlier, ISO 29481 Part 1 requires the inclusion of header section and overview section in IDM, any IDM specifications. So we interpreted header, which includes the specification identifiers and a change log and so on, the author information, as the spec ID and authoring elements in the schema. and we interpreted the overview section, which includes use case, cases, and aims and scope, and target project phase, and so on, as use case element in the schema. Another major issue was what IDM is in the IDM schema. Although the entire thing is referred to as IDM, the relationship between the IDM and IDM components were not clear in terms of data schema. So we thought hard about what IDM was from a data schema point of view, and we learned that IDM could be viewed as a wrapper of its subcomponents. Another analogy that we use to define the relationship between IDM and its components was the folder analogy. In this case, you can view UC, use case, as a label of the folder, and the empty folder can be filled with process maps and exchange requirements, so that they can be contents of an IDM. Another issue was how to represent the relationship, such as IDM can be composed of sub-IDMs, multiple sub-IDMs, and ER can be composed of multiple ERs, and so on. We represented these relationships as a recursive relation. Another issue was how to represent the connection between IDM and external schemas. MVD, we are often referring to MVD as a subset of IFC, but ISO 29481 Part 1 defines MVD in a more generic way, so it can be a subset of any open standard data schema used in our industry. So it could include not only IFC but BS, Building Smart Data Dictionary Schema, or the CDGML and others. So the question was how to link the IDM to these external schemas, or MVD schemas, and we decided to do it through ER, and ER can be mapped to not only to one MVD but to multiple MVDs, so that if there is updated version of, for example, IFC, then the IDM specification can be mapped to the updated, also to the updated IFC schema without recreating the entire thing. So this is the current draft of the IDM schema in class diagram. It may be updated throughout the discussions in the future. So what is the current status of the IDM schema project? This proposal for the IDM schema was accepted as a candidate for the ISO 29481 Part 3 standard in August 2020. We are working on the 24-month track to publish the ISO 29481 Part 3 standard by July 1st, 2022. In addition to the ISO committee review process, we are validating the schema through the implementation and testing of prototype software applications. Thank you for listening to the presentation. Thank you.